YouTube channel. I'm Greg, and on today's show, we're going to be taking a look at Alpine Linux commands for Raspberry Pi and other Linux distributions. So let's go ahead and get right into it. So some of the commands that we're going to be covering today are going to be things like APK for package management, how to deal with networking, and then also how to check the current system utilization, like how to determine how much memory you're using, how much RAM, what processes are running, things like that. And actually, before I start, let me quickly change this display setting. So if you're ever in PuTTY and you want to see the text go bigger, if you click in the upper corner and go to Change Settings, or you could do this before you start, you can actually go to Appearance and change the font. And in this case, I'm going to make it size 20, and hopefully that'll be enough. So that should be hopefully a little bit easier to read. So starting out, I'm just going to switch my view back here. There we go. So starting out, we have APK. And APK is a package manager. There's also apt for Debian distributions. And Debian is like Ubuntu and Debian itself, as well as a whole lot of other variants of that. And this is very similar in terms of its format, but the actual specific command is different. But the end function is actually the same. So if we do APK, we can see it tells us what we could potentially do with it. So we can add, remove packages, fix, upgrade, update, cache, which is actually very important, things of that nature. So let's say we want to add a package. In this case, let's say we want to add FFmpeg or something of that nature. Let's see. We could add a font. I actually think I have FFmpeg installed because, again, this is the distribution that we have, or the image that we used for creating the clock. But let's just do the command FFmpeg. And FFmpeg is a tool for displaying and modifying video. So it's actually a very, very powerful tool in terms of what it's able to do. So when we actually type that, we see that first thing it does is it updates the current package list, and then it will go through and install the constituent packages that are needed in order to be able to make the program run successfully. So it's not just the base program that it's going to install, in this case FFmpeg, which we will see at the end. It's all of these other packages that it needs because the base program references that. So it's really very, very effective in terms of you don't have to actually know everything that it needs. You just have to know what you want, and the actual APK program will install everything you need. So now that it's installed, we could type FFmpeg, and we come up with a command saying, what do you want to do? You know. So we're not going to do anything in FFmpeg right now. We will in a future video. But for today, we're just going to keep it to APK. So if we go back to APK and we look at another one of the available commands, which is delete. So if we wanted to remove FFmpeg, right? So we installed it, we did what we need to do, or we decide we don't need it. We would do APK del, and then just the name of the same name that we used in order to install it. Now it's a lot faster, again, and it's purging all of the data, everything else like that it installed, and leaves us with 84 packages that were removed, and we're back down to 81 megabytes of space. And the nice thing about Alpine is because it's based on LBU, things like that, until you type LBU commit in order to actually save the work that you're doing, specific to Alpine Linux again, but in order to save that work that you're doing, it's not actually going to save it. So you can try out packages, things like that, and if you don't like something or something gets messed up, you can actually just reboot the machine and it will load the last saved config. But if we did want to save this, for example, we would do LBU commit. And another option, of course, is LBU commit -d, and that would delete whatever that previous version is, opposed to incrementally creating a version commit. So when you actually just do lbu commit, it will come up with a dated version for what the last configuration was. And then it will create a new version, alongside of it, where D will just overwrite it. And LBU is effectively the saving system for the system state. Because this is all running in RAM, once you turn off the machine, it's not going to save any of that data that's only in RAM. So LBU writes it to the hard drive. So both of these work together, so APK and LBU. Now, when you're doing things like upgrading on Alpine Linux in particular, APK has some very, very good tools in terms of getting your packages installed. So you have fix, update, upgrade, cache. And I say cache instead of cache just to differentiate. But if we wanted to, for example, update the packages that are on the stored media, we would do apk cache, and it'll give us its own list of things it could potentially do. I thought it was, but we could do apk cache sync, and that will actually synchronize the current package state on the drive with the current packages that are installed. So a place where this is useful is if you have, for example, different package versions that you just downloaded as part of installing another package. This will actually commit it to your wherever you have your cache defined, your cache defined. And then we also have clean, which will remove unnecessary packages. So for example, let's say you have packages that are no longer the most current version and it's just taking up space on your drive. You can use clean in order to be able to get rid of them and only save the most relevant versions. So APK update, all that is it will go out to the internet, download the current available package list and the locations of all those packages where it can download it, and it will actually store a local database that APK can then use to be able to install packages from. So it does a lot of stuff in the background, and in this case we see that there are 19,348 possible packages available, and a lot of them will reference each other, but it's quite a few packages to be able to choose from. And one of the ways that I like to be able to choose from it is using the search function. So if we do apk search and we type in a package name like PHP, it will give us all of the possible packages that contain PHP in either the name of the package or as an executable or a file included in the package. So it even goes deeper than that. So some of these you'll notice, I'm going to try and see really quick if we have an example. It may not with this. So gRPC plugins does not have the word PHP in the title, but there is something inside of it that is included that is called PHP. So that's just an example. So we can use that to be able to find the names of packages and also what the current version is. And I'm not going to go into how to specify, specific versions, things like that. That's getting too much into the weeds. But just knowing that this exists, if you ever have package problems, things like that, where it says it can't find it. So if it says it's missing dependencies, usually the cause for that is that you don't have it in a repository that you currently have mapped to your machine. So to edit the list of available repositories, and we're going to use VI for this, which is what we covered in the last video. If you didn't see that last video, be sure to check it out. It's part 1 under the same name. But VI, it's going to be /etc /apk /repositories. And actually, let me clear the screen before I do this, just so you can see it. Right, so that's it right there. We hit enter. Now we can edit the file. Now, normally what happens is the community entry will be here by default. But in this particular case, it will be hashed out. So it will look like this. So it'll have a comment at the beginning, so it ignores it. And if we actually look at that effect, so I'll save this out, and we'll run apk update again. We see that it only used one of the two repositories. I mean, it had the local repository as well, which is the local drive. But it only has 5,183 distinct packages available. And, you know, that's quite a reduction versus what we had before, which was the 19,000. So if you do find that this is the case, and we can't, for example, if we do apk search PHP again, the list is quite a bit shorter. In fact, it doesn't even have any of the PHP installers that we would need in order to be able to do that. So we would have to include community as part of that. So we go in here, we can either hit the delete key or hit I and then delete. Escape WQ. And when we run update again, or search, it will automatically update, but I'll do update again. We see that it does, in fact, it is back to the 19,000 packages. So definitely something important to know is that if you can't find it, maybe you don't have the right repositories defined. So using search to be able to verify that you actually can see the package that you're trying to install is a good troubleshooting method, and then editing the repositories list will make sure that you have the right repositories defined should you need to add to it. Next is apk upgrade. Let's clear screen. So upgrade will actually go through the available packages and will automatically pull the latest version. In this case, we see we're going from some versions back and are improving those to be the current latest version. So nothing you really have to do, it's automatic, and it will automatically replace those packages. After we do that, let's just make sure that everything is automatically synchronized to our drive, because next time we reboot, we want to be able to preserve that. So we're going to do apk cache sync, and we want to clean out the old packages as well. So I'll hit the up arrow to pull up the last command and do clean. Now we want to save it to the drive, so we do lbu commit, and in this case I know I just want this current version. I don't want to save the previous version for this, but that's based on your comfort level and how confident you are with the modifications that you're making to be able to choose to do that. So now when we reboot the machine, it will actually come up and be in this current state that we're at right now. So, and then the last thing I want to cover is just info. So apk info, or at least for apk, the last thing for apk info, and then typing the name of a package. So if we do php, we can see what options we have. We have 8.1 available, we have 8.2, and it tells you the installed size, it tells you web page, things of that nature. So that way you can actually go through and determine what packages you want to use, and also get additional information should you choose to investigate it before you install it. It's very good in terms of validating packages, especially if you don't know the author, to be able to try and make give yourself a little additional peace of mind that you're not installing something malicious. So that's kind of the details and the baseline for APK. It does have a lot more options, but again, you can use --help anytime on any command to get a list of what its full capability is. And also being able to search online and get a better idea of exactly what's available or how other people are using it is great to get examples to get you started. So let's start with networking. So ifconfig is the baseline command, and this will kind of tell you all of the details relating to the hardware that you have. We see that it says link encapsulation, that's what encap is short for, and it says Ethernet, because Ethernet is a protocol for data communication. It's not actually the physical medium. We see the hardware address, and in this is the MAC address. So if you needed this for some reason, for example, setting a static IP through your router, you could use this. We see the assigned INET address. So that doesn't stand for internet, it stands for interface network address. So critical distinction, because it'll show up the same if you don't have internet. And it shows our current IP address here. It shows the broadcast address, which usually is actually is the 255 variant of this. So it'd be, in this case, 192.168.15.255 is usually the broadcast address for each subnet. And that's based on the subnet mask. And we're not going to go deep into networking here. That's probably a different video. But 255, 255, 255, 0. And just a broad overview there. Everywhere where you have 255, the numbers have to match in order for the computers to talk. And everywhere where it's a 0, it has to be different. So that's just kind of a high level. There's different numbers in between there, things like that. And it's easier to represent it as bits. But again, that's another discussion. So we have an INET 6 address, which again is interface network 6. So for IPv6 address. And then it gives us this right here, which in this case is automatically generated because I don't use IPv6 on my network. And in this case, it just says the scope is link. So link is up. Then we see some stats about it. So we see the connection is currently up. It has broadcast. It is running. It has multicast support. The MTU, or the maximum packet size, is 1500. The metric is 1, which means it's going to use this before it uses any other interface when accessing the network. And it gives us some stats. It tells us RS packet, the received packets, the transmitted packets, and then if there's been any issues. So it'll say if there's errors, any dropped packets, overruns, which are buffer overruns, frames, carrier, and then collisions, and then the transmit queue length. So if there's a lot of congestion, you're trying to transmit a lot of files, or transmit a lot of packets specifically, it will start putting them in a queue. So if it exceeds this queue, then it turns into an overrun condition. So as long as it doesn't exceed it and it manages it effectively, these should all be 0, except for this, which is just a static value. And then it gives you the amount of received traffic in bytes and the amount of transmitted traffic in bytes. So the interface that we were just looking at is called ETH0 for Ethernet 0. And that's actually the generic name that it gives the physical network adapter. So a variety of manufacturers, things of that nature, will all be named ETH0. If it's a different format, it may come up differently, and that may vary by manufacturer. So if you have, for example, fiber adapters, things like that for servers, those may show up a little bit differently. Or if it's a proprietary type of interface with a special driver, that may also show up differently. But using the generic Ethernet driver, it will show up generally as ETH0. Different operating systems, things like that, may have a different default name, but in Alpine, it is ETH0, which is useful. The other entry that's defined here, because again, this is a Raspberry Pi, it only has one network interface by default, unless we add a USB adapter to be able to give it more interfaces. But the low interface is actually short for loopback. And what loopback is the way to address yourself. So it's kind of like saying me. So if I say me, I know I'm talking about myself. If I say low, if I address a packet going to the low interface, or going specifically to 127.0.0.1, I know it's going to come back to myself and go to a process that's on the same machine. So that's all it's referring to. It is always 127.0.0.1 on every machine, including Windows and on Mac. It's a function of the standard. And in this case, we're not using it. So that's ifconfig as far as what its output capability is. It does have the ability to modify it and things like that, but in practice, I would be wary about doing that. It will not save anywhere, and it will only be for the time that you run it, even if you run lbu config, or lbu commit, excuse me. So realistically, it's better to set it through files and then initialize and start the actual network adapter in the with the correct settings than it is to actually try and modify it on the fly. That's my cat coming to say hello. This is Nala. She's a very good cat. We'll see if we can keep her from meowing in perpetuity. So the next command is also ping. So remember how we said that loopback, the 127.0.0.1, will actually send any information that we send out back to ourselves. If we use the ping command, what this is going to do is it's going to send a packet out, see if a host is alive, and then return a response if it is, or tell us that the packet timed out. So if we ping to 127.0.0.1, we can see we get a reply. So it's sending a 64-byte packet from 127.0.0.1, and it's going to 127.0.0.1. And it's showing it's going to continue to run forever, and the total time that it took in order to do that is 0.174 plus or minus milliseconds. So it's really quick, which I hope it would be because it's on the same machine. So let's go through exactly what it said here. So we ran 30 packets, 30 of them were received, and I did Control-C, by the way, in order to exit that sequence. So there was 0% packet loss because 100% of the packets were transmitted and we received a response. So the round trip time was averaged 0.1, or excuse me, the minimum was 0.163 milliseconds. The average was 0.173 milliseconds, and the maximum time that any packet took was 0.205 milliseconds. So based on that, if you see a broad range in those statistics, that actually means that you have instability in your network connection. Let me see if I can do something with the cat really quick. It's good there's nobody watching, otherwise that would be a bit annoying. So, and to be honest, she has a door. She could probably come back in. So let's see. So the ping command itself is very useful in terms of being able to do diagnostics on your network to make sure it's both communicating as well as being able to, verify what your connection stability is. So if you see a large variation in the numbers between your minimum and your maximum, obviously the packets are not transmitting very well. There's going to be a lot of buffering, things like that in the middle that can cause a lot of latency. And if the numbers are very high, that is just straight latency. So certainly something that you can learn a lot from. And I'm not going to go through a lot of the detail. Actually, I'll just breeze over it really quick. So we saw the 64-byte packets. It gives you the sequence number to let you know how far you are through the transmissions, things like that. I just happened to stop it at 30, but that would show whatever the total number of packets were that you sent and received. TTL stands for time to live, and it shows that it will do 64. So this is more of a networking discussion, but 64 hops actually relates to how many routers that it can go through before it actually just times out. And that's to prevent packets from living forever, especially if they're going in loops, things like that. You want to have it eventually stop, otherwise they could accumulate and potentially just keep transmitting in circles forever until the device is powered off. So that's why TTL exists, that's what that means. And you can set that to different values, things like that, but we're not going to go into that here. So that's how ping is used. Let's try ping on Google. So we will ping and make sure we can get to the internet. So pinging google.com. We see that in this case, the Google address resolves to 142.250.65.238 for my region. Again, this may change just based on load balancing, things of that nature. And this is what's called a DNS resolution. So it translates the name google.com to an IP address that it can communicate with. And so we see the responses coming back from that address are coming back. So we transmitted 8 packets. We received 8 packets. There was 0% loss, which is good. Our round trip time, the minimum was 3.682 milliseconds. Average time of 11 milliseconds with a maximum time of 29 milliseconds. So even though that seems kind of large, it's not that far off. You know, it's not in the hundreds or even like the thousands, which would be full seconds. That's where you would see a lot of deviation and a lot of potential disruption, especially if you're trying to stream video or other things like that. So this overall is pretty good. But you could tell that it's taking a lot of different paths in order to try and get there just because of that variation. So the next network tool is netstat. And netstat's very useful in terms of trying to do really deep diagnostics on, anything, anything involving a network. It's just going to dump all of the current open ports that you have to let you know exactly what, to let you know what is communicating with your laptop or with your computer or what it's communicating with. So in this case, we see that I have a TCP SSH connection, and that's really the only thing that's currently connected. Right, and that's what we're looking at here. And then we see a number of other things in terms of datagrams, there's a stream, things like that on the Unix shell. And they're just Unix sockets, so things like cronid.sock, but this is local. So all of this stuff is the potential entry points for hackers, things like that. So if this was just an open port to the internet, for example, if I opened up SSH to the internet and I saw somebody was logging in, I could actually see where it was coming from using netstat. So it's a good diagnostic tool for that, but also it's good to make sure that your connections that you want to be up are also working. So if you were connecting into this machine from another machine, like I am here with this SSH locally, you could actually verify that it is in fact succeeding in reaching it and not related to, like, for example, a firewall issue, a routing issue, or a network issue. So if you had like the wrong network subnet and it wasn't compatible and it wasn't able to communicate with the computer at all, you wouldn't have anything showing here. So this is a very good tool for being able to do that type of diagnostics and complements the ping command. So for the ping command, you're reaching out. With the netstat command, you're actually looking at what's already existing, what's in there. And if you saw pings, for example, coming your way, you would actually have those show up as well. So the next command, which I'm not going to be able to demonstrate, but I'm just going to talk about, is clear, is wget. So wget is actually a tool for being able to download things through command line. And there's not really something as elegant as this in Windows. It does exist on Mac because Mac is Unix based, but at the end of the day, wget is really useful in terms of headlessly, or at least without having a graphical display, being able to get files. So pretty much the way you would do that is you would just do wget and then the address, the web address of the file that you actually want to download. And in this case, I don't have anything, a particular web address that I can go to, but it would be https:// the address. And in fact, let's just do the homepage for google.com. It will do that. It will download whatever you tell it to, and it will just do it verbatim. It won't follow it through and necessarily do the dependencies, although there are options for it, as well as a lot of other functions here that we're not actually going to go through. But let's just see what it does. So it's connecting and it downloaded the index.html. If we ls our home directory now, we can actually see index.html listed there. So if we vi, or actually let's do less, which is another command that we covered last time, and we do index.html, we can see this is what it actually looks like. They don't do pretty print on their code, but realistically they don't have to. But it's quite a bit longer than you would guess based on how simplified everything looks on their interface. So you can use that for images, you can use that for videos, you can use that for web pages, whatever you want to be able to download. That's how you would do it there. So let's move on off of networking and let's move on to system information. So let's say we wanted to see what our current free space is. And I'm sorry, free memory. We could actually just use the command free. And that tells us how much memory we have total, how much of that is used, how much of that is free, how much of it is shared, how much is being used as a buffer or a cache, and how much is available. And it has a few options as well. One of them, it doesn't really have a good help file, by the way, so you do have to look this up. But if you do a -h, it should give you a human-readable format, which will, in this case, show you as megabytes. So because this is a Raspberry Pi Generation 3B+, we see that there's 922 megabytes of RAM available, because, of course, it's using 64 megabytes for the actual graphical output. And then from there we have, or I believe we actually might have increased that, but you know, it's got a gig of memory total, and some of it's used by graphics. The system is using 34.3 megabytes total. There's 662.6 megabytes free, which means that there's nothing on it. And then there's 93.4 megabytes shared. Now, realistically, I will say that usually includes your packages, things of that nature. So just something to keep in mind. So anything that's not a part of the image or part of the OS in Alpine Linux that you're running tends to be within that. And then you have your buffer cache, which could include other things that you're doing, and it may not be currently utilized memory. It may be able to be given back, and it will manage that. So, but this technically counts as available memory. So, or some of that does. So, there's quite a bit you can glean here, and specifically the amount free, the amount available. If those numbers drop to 0, your computers may crash, or it may just not be able to manage itself, or it may start using swap memory. In this case, because we're running it embedded, there is no swap memory defined. So it actually has nowhere to go. So if you're running an embedded system, always be careful of how much memory you're using. You may need to increase it for the type of application that you're trying to use it for, but realistically, you need to just make sure that you're staying within the means of your hardware, or changing the hardware appropriately, or changing the code to be more efficient. So that's enough said on that. If we want to see a bit more of a better display in a pseudo-graphical format. Now again, I'm on PuTTY, so everything is text here. or at least is transmitted over text. If I type top, T-O-P, what this will do is it will give me a current running process, similar to the task manager in Windows. This will actually show us everything in real time as far as what's actually running. And it's, 1 second refresh time, 2 second refresh time, depending on what you said. But it shows us the amount of memory used, the amount of memory free, shared, buffer, and cached, etc. So, that's very similar to free does all on its own. But in this case, it includes the CPU percentage for utilization, and then how much of that is being used by the user. Right, so a CPU percentage up here as a total. Then user is currently using 0%. Okay, system is using 0%. Network interface is 99%. Again, because we're using network in order to be able to communicate with the machine. Idle is 0. I/O is 0%, and I/O refers to the disk access. IRQ, which is interrupts. Everything else like that. And I should specify it's the other way around. So 0% user, 0% system, 0% NIC, 99% idle. I should say that right. Probably going to trim that out as trim that out in the edit afterwards. Or not. Who knows? We'll see. We all make mistakes, so just keep that in mind. But 0% I/O, 0% IRQ, 0% system IRQ. And then it will give us our load averages. So you have 1 minute average, I believe 5 minute and 10 minute average. Doesn't really matter, but you'll notice that these will effectively be floating point integers or floating point numbers associated with what the average of the CPU utilization is over time. And currently what we see running is we see the NTP clock running in Python 3. We see Crony, which is doing our NTP synchronization. And we see the SSH shell, as well as a bunch of other stuff. And a lot of this is all related to system processes, things like that. So it's a very useful tool. It's very helpful in terms of watching how the system is performing and how everything is running overall. If you see everything pinned at 100%, you probably don't have enough CPU power to be able to run the application that you're running. Especially if you're seeing lag, using this as a diagnostic tool is very handy. And the nice thing about using it over SSH is you can technically open up multiple SSH windows on a single machine and create multiple connections, be able to run this in one of them while doing work on another one. So, very handy. So we talked about network and system utilization, things like that, but what about hard drive space? So if we do DF, so drive free, think about it that way. If we type DF, it will tell us how much is currently being utilized on our system, how much of our space for our respective drives. Now, the way it shows up here is all in bytes. That's not really usable, so let's do DF-H again. And now it will give us a human readable format for how much space is available and everything else. So we see there's a dev tempfs, 10 megabytes in total size, 10 megabytes available, not using anything. A shim, 461.2 megabytes, and we see 0% is being used. Next is dev mmc blk0p1. That is actually the physical hard drive that we have that stores the OS and configuration. That is our SD card, right? So it stands for multimedia card block device 0 partition 1. That's actually what it stands for, but again, it's just the name of the drive. And we see it's mounted in media mmc blk0p1, but it's a 32 gig drive, so it shows up as 29.8 gigabytes. There's currently 228 megabytes used, and we have 29.6 gigabytes available, so about 1% utilization. Then we have tempfs, and again, this is actually on Alpine Linux. If you don't have it installed to a disk, this is going to show up as half of your RAM. So whatever half of your RAM is, will show up here. And actually, when we looked at it earlier with the free, I'll pull it up here again. So here we see there's 461 megabytes available. We see there's 922 megabytes total. We are currently using 93.3 megabytes. And we see here in shared 93.4 megabytes. See that correlation? And then we see amount available, etc. But this is the slash. So this is our root directory. And that's actually what everything is virtually installed to. Because since it's running from RAM, it technically creates a hard drive on your RAM, installs all of the files there every time it boots up, and then you run off of that as if that's your hard drive. And then here we have a little bit of reserve space in order for /run. That's just for while programs are running, things of that nature. A dev/loop 0, which is mod loop. Don't worry what that is. It's just another segmentation of RAM. Things like that. So it's very helpful in terms of figuring out if you're close to capacity. So if you start trying to do things and it says that you're out of space, you would use this command to be able to verify that that's the case or find out where you're out of space. And a lot of times when you are doing embedded systems, if you don't have enough RAM and you're trying to do it and it's consuming all of your RAM with the files that you're trying to install, it will show up with 100% use here and it will start giving you errors. May not crash immediately, but certainly something to keep an eye out for. And then the last thing in terms of getting details on your system that I'm going to show you is the uname. So uname is just pretty much some details about the core OS. So if you type nothing after it, you'll see it'll just say Linux. Right? So what is it? Unix name is Linux. That's what uname stands for. But let's say we wanted some more useful information. So if we do uname and then -a, it will tell us what our current version is. It will tell us the name of the machine. It will show us we're running on RPi. It will show us the build date of the actual version that we're running, the architecture, and that it's Linux. So it can be helpful in terms of detecting what kind of system you're on. If you're on an ARM-based machine or if you're on an x86 or 64-bit machine, it will tell you using uname -a. So. And then the last things that we're going to take a look at are shutdown and reboot. So shutdown will actually turn off the machine. And we see that it's not found here. When you don't have it installed, the actual normal way to shut it off is to unplug the machine. So if you have it running from RAM as an embedded system, there is no need for a shutdown command because unless it's actively committing something to disk, there's actually no volatile time. Everything is read-only, except for the RAM, which is going to go away when it turns off anyway. So normally you would just unplug the machine. There is another command called halt that you can use, which will just stop execution. And that can be useful in terms of making sure it's not actively writing to the screen. But you don't use that a lot. You just unplug the machine. And then the other option is to reboot. Now when we reboot, because we're on SSH, we see it said the remote side unexpectedly closed the network connection. And that's because it's in the process of rebooting now. We see on PuTTY that it went to inactive. So because of that, we can't actually type anything here because there's no connection to any other machine. Now, notice I'm stalling here because I'm waiting for the other machine to finish booting back up. So I think enough time has passed. So if we click in the upper left-hand corner here and we go to restart session, if it's ready, it will ask us to log in again. So we log in, I'll clear the screen again, and we see that now it is back at the last state that we saved. So it's really useful. You don't actually physically have to be at the machine in order to be able to do that. So if you run into problems or you find that it's not behaving correctly, a reboot's always the best first option if you know that there's no data that you need to save. So that's going to cover this tutorial. There's some more advanced commands and scripting that we're going to get into in future videos. But I just wanted to give the part 2 for what the basic commands are that you should know in order to be able to to what the basic commands are in terms of what you should actually expect and what's a good place to start to be able to get into Linux. So if you like the video, be sure to hit that like button and leave a comment down below. If you're watching this after the fact, this was a live stream and now it's a VOD. So I definitely appreciate you watching either way. So if you're not subscribed to the channel, be sure to hit that subscribe button and hit that notification bell. That way you know the next time we're getting extended. So until then, take care as I search for the stop stream button. There we go.